asset management for a modern data center. And for this, I would like to invite on stage Mr. Akilur Rahman, who is the CTO at Hitachi Energy India. Giving a brief introduction, Hitachi Energy India is a leading technology, digitalization and innovation in the Indian market while supporting market innovation in South Asia. Mr. Akilur carries more than 3 decades of experience in research, R&D, technology management, engineering, consulting, business and product development in the fields of power, automation and digital technologies. With this, please welcome Mr. Akilur with a big round of applause.
Hope you can hear me. Okay. All right, so hope you had good lunch. This is one type of energy, rather fuel, which doesn't really make you energetic, right? Any other type of energy really makes you energetic, but we'll try. So, I am from Hitachi Energy. So, I have been in the energy and power domain more than 3 decades. And energy power domain was one of the earliest adapters of today what we call data center, data, digital simulation, things like that. So, from 60s, 70s, we have used software, digital automation in power systems because that was the need. Need because power system works, the electricity works on 20 millisecond cycle, sine wave, and each millisecond counts. So now I say that data and energy both are carried by electrons, but the energy needs more deterministic. So there is something called deterministic nature in the computational power and also the transmission of data, storage of data. So that means, whereas in the IT field you talk about latency, but here we talk about determinism because within 1 millisecond if a software has to run, taking the data from sensors, actuators, run the algorithm, provide commands to the actuator, whether it is in the power or process plants, then it has to work within 1 millisecond. More than 1 millisecond can really create disaster. It can create tripping of a line, tripping of a circuit, and it can lead to tripping of another circuit, cascaded failure, blackout, and you can imagine the blackout not only in our social, society, community, city, but also in the plants, in the industrial plants, very disastrous. So with that, I will start with how important is asset management. Asset, whether they are power, energy assets, they are IT, hardware, software assets, or they are thermal cooling assets. And in a modern data center, how they are important and they are getting more and more important, and then how they are also getting more in terms of having the financial gain, cost saving. So there are key drivers for modern data center. Climate change, as you know, I mean these are the topics which are very known to everybody. Climate change, sustainability, and demand for internet. So I mean, no need to expand that. I think it's increasing. And safety and security, very important. Security of data, security of IT, hardware, software, but also the safety, which can be the outcome of breach of security, cyber security. And we know that uptime of the infrastructure for the data center, whether it is the energy, the power infrastructure, the IT side, it has to be 99.999%. So very, very stringent requirement. The entire system, the domain system of energy, power, cooling, IT, they have to work in this. And also the automation, the control, the protection, they also have to fulfill this 99.99%, 999% availability. And you know that why it is required, because these are all now need for e-commerce, data, IoT, digital, and machine learning. And it's also sort of, we need data for doing this as well as these, they also need data for doing the application like energy. Energy and data, they are two sides of a coin. You need more and more energy in the data center to have the computation storage. At the same time, you can also we use the data for energy efficiency, for energy sustainability monitoring, and asset performance management. So you know that sustainability, the carbon neutral net zero it's called, that target has been set by many countries, many industries, data centers, they are actually ahead. A lot of oil and gas industries are also ahead. And 2030, 2050, like that, the targets are set. That doesn't mean that we don't have to do anything, because it's 20 years down the line, 30 years, so doesn't mean that the action already has started, how to get the renewable power, energy for the data center. It's green data center. Just a question, very simple after the lunch. So what is the net zero target for India, which we have announced? 2070, that's right. 2070 is the the net zero target we have in India. And what is the major target we have for India for renewable energy? Yeah. 5 gigawatt? Okay. Anybody else? It's 500 gigawatt by 2030. So 2 zeros missing. So half of the electrical energy by 2030 in India, we are targeting to have from renewable sources. Solar power, wind power, and of course there are different ways to store them, battery energy storage, hydrogen power, electrolyzer based, green hydrogen it's called. And these are also need by many of the data centers, because they want to be carbon neutral, whether it's Microsoft, the hyperscalers like Microsoft, Amazon, they also would like to be, they have announced already to be carbon neutral. That means they are going to use these energy, the renewable energy. That's why it's growing and it's on the path of achieving. Now I come to the assets. Asset management, whether it is the energy, the power asset, you know that data center, they are the power guzzlers. And more and more, the same data center, when your computational power is increasing because of AI, ML, blockchain, then you need more power, more cooling, more data. So it's going to be more and more dense energy, data, and then thermal cooling in the data center. So that's why we need to ensure that the assets, the devices, equipment, and machines, whether they are IT, hardware, or electrical or thermal, HVAC, so they have to be reliable. So that's why we use this for the concept of data, the asset management here. So how do you do that? So asset, of course, they will have, I take the example of a transformer which is feeding power to the data center. So that transformer has the offline data about its design, about its manufacturing, about its material which is used. And just imagine transformer, if it is malfunctioning or failing, it can lead to total shutdown of power. If it's one transformer, half of the power to the data center will be off. If there are two transformers, both of them they fail, then the entire data center will be out of power. So very important. And it takes, we take the data also from SCADA, from the BMS system, or maybe DCIM, and then we also put online sensors in the transformer to get the data. The system gets the data, and there is a model built which is based on the predefined mathematical algorithm. Also the AI/ML, because we need to bring in the predictability based on the transformer operation in a data center. So this is called asset health management, the model, the mathematical model, predefined as well as AI/ML based. So why we do it? We want to have the anomalies in the transformer detected early enough and predict the failures, malfunction in the transformer and top failure so that you can have the spare parts, and to ensure that before the transformer malfunctions or fails, you either service it, repair it, or have some backup plan. Because we want to reduce the downtime. I mean, you know that availability is 99.99999%. So that's why here we use the technology of monitoring, of diagnostic, predictive, prescriptive maintenance, and also gradually use the AI/ML, artificial intelligence, machine learning to achieve better predictability in the system so that we can repair before it fails or malfunction. So this is a curve which says that how we can progress if we have the assets. We already have a data center where you have the assets there, but they are not fully digitalized. They are not sort of connected with the asset performance management system. You can always start with offline data I talked about, and you can also connect it to the SCADA, DCIM, the data center information management. You can also connect it to the BMS system, and with that you can get the statistical, the mathematical algorithm running which can predict. But that prediction may not be very accurate. So what we do is we take more and more data, put more sensors, and then start putting the machine learning system, which will learn the behavior of the transformer, of the assets, the accessories of this, and also the operating condition. And then finally, we can also have artificial intelligence by which the action, automatic action in the SCADA system, in the DCIM or BMS can be taken so that the downtime of the data center is prevented. And here, of course, we use different technologies, including robotics. For example, we as Hitachi Energy, we have developed a robot which can do the inspection of a large transformer, which can be size of this hall. It can do the inspection. It's a diver robot which goes inside the machine, the transformer. You don't have to, disassemble the transformer. So instead of 3 weeks of downtime, it can do the inspection in 2 days. It's connected, remotely connected. It's controlled, wirelessly controlled, and then it also runs algorithm to predict any failure, malfunction, depending on the observation in the transformer. So these are the technologies which are there. It's not just one asset, whether it is in the energy feeding to the data center, the energy system, the power system, the substation. These assets are connected. You have transformer, you have switch gear, you have the disconnector, you have also the power quality. So they are all connected. So you may protect transformer, but something else fails, malfunctions. So that way you have then downtime, the tripping happens. Yeah. So here what we do is we take the entire system and then decide the importance of each component, the equipment, the criticality of this equipment, and then map it in terms of reliability mapping. So it is again case-to-case basis. So what we do here is from time-based, because normally in traditional way you have the time-based management of maintenance of the transformer. So every 6 months, 1 year, but something can happen in between. Within 6 months or 1 year, something can happen and it can fail. And then we move to the condition-based maintenance depending on the condition. But now, having the system in place, the complete feeder which is feeding to the data center, all the equipment, mapping them reliability point of view, and then you can have the approach by which you can attack the equipment asset which is most vulnerable in terms of malfunction or failure. So that is how we move from time-based to condition-based to reliability-centered maintenance to ensure that the availability of the power, the energy is achieved, 99.99%. This, you may or may not have as data center owner operator, but you can always move from the time-based to the reliability center, which will increase your KPI in terms of availability. So there are different digital technologies we also use in a data center specific the assets. So this is applicable to whether it is power, energy, or cooling in the data center or the IT hardware. So you can have a digital twin of the entire data center and all its building blocks. Building blocks, I mean the energy block, the cooling block, and then the data hall, the IT. So we have developed, as Hitachi Energy, we have developed for the electrical installation, the energy installation, a digital twin, which you can use for, let's say, training your maintenance operation staff. You can also use them to find the performance of the asset, the health of the asset. You can also see how they are designed, how to optimize it in terms of cost, efficiency, and also the reliability. So this can be done even without touching the hardware. So as you know, the digital twin, which is exactly physical, is a software replica of the physical system. So this helps in training, helps in designing, redesigning, optimizing, and also sort of getting the insight into the health of the assets, health of the operation, health of the system. So it can be for any block, as I said. So we have done it for the energy block. So this can be done for data hall. Maybe it's already done. Some people, some companies, they have already done. But this is a very useful tool. And we know that the next generation, which is going to come, they are all more tech savvy, digital savvy. They would like to. So they don't have patience to really, do anything in the domain, in a persistent way. So that's why we need to train them with this technology. So very important one. There are other technologies which are also used, we are using for the asset for the data center. So starting from virtual reality, augmented reality, I talked about digital twin, and AI machine learning is, of course, that is area what we say that to get more predictability in the asset condition, performance, time sensitive networking, because the cooling, the thermal network, the electrical network, they work in different time domain. So we need to have time sensitive networking so that we can have the actuators in place to prevent any failure and also protect the system. Blockchain, connectivity, 5G. So these are all very important things which are digital technologies which are used. And what we see here on the left side, you see that is the core system, the data center core domain, which is the power, energy, and also the cooling, the BMS there. And that has been always a closed loop system. I talked about this technology, SCADA, network control management. They have been there since 80s, 90s, but closed loop system, the digitalization also you can say that started in 90s in power domain. But today we are also putting more sensors, getting the data, having them in the cloud so that the data, the application, they are available for the larger set of experts who can work, who can predict, and then make the performance of the system data center better. And then here the KPIs can be productivity improvement, the reliability improvement, quality, energy efficiency, environment, safety, security. That has to be basically using all these digital technology. There are examples also to do this. And then you need to have like integrated monitoring, protection, control, and asset management, the center, which can take care of all the different aspects which are very important. Important basically to ensure that you track, and also the system tracks, because you have the AI/ML application running, and the system will automatically track, make it self-healing also many times. We need that for the data center. That means any, let's say in the data hall you have cooling imbalance happening, so automatically the coolers and all, they can be sort of controlled automatically with the AI/ML, so that the distribution of the coolant is even, and also wherever it is required can be more in the hotspots. So cyber security is very important here for the assets of the data center. So again, asset in terms of the power, energy asset, or the cooling, the thermal assets, or the IT hardware asset. So there we need to have threat modeling, because you know that how it may be easy for ethical or unethical hackers to get in, and then this is the biggest impact they can make, because if the data center power or cooling or IT hardware fails or malfunctions, you have so many people, society, they get affected. So the impact which the hackers they would like to have, and also the financial gain they would like to have, it's much more. So they're very, very vulnerable. So we have to do for each data center a threat modeling. You do the system even before the hardware, the system is installed, commissioned. Before that, whenever you are on the drawing board, you can do this threat modeling to ensure that each and every device, connectivity, the server, the data hall, the power system, everything is sort of having a defense in depth approach. So now a lot of wars going on. So we know that defense in depth comes from, actually from the army, the defense. You need to bring, you build a core. So your core has to work, your power, for example, has to work, cooling has to work. So all the, so then it is made in concentric circles. So core, and then you have circles layers. So then you have to ensure that the core, the central circle is always protected. And even if there is attack, there is infection, malware, so the system can still work. So that is the philosophy here, threat modeling, and then the defense in depth approach. So this can be also for extending, when we extend this system to IoT with cloud computing. So this is again for the asset, we need to ensure right from the IoT, the sensors to the edge, to the cloud, they are all monitored. And there is also a vulnerability, the mitigation approach already in place in terms of automatic isolation of the system, or maybe with human intervention, this is possible. And then finally, it is also how do you ensure all these KPIs, what we talked about, they are actually defined in terms of services. So for the owners and operators as OEM and also together. So it's a collaborative approach, how you can make it. And the question is always that where do we start from? If we already have a data center or maybe a new data center, it has to start from, of course, planning phase. If you already have a data center, then I'll come to that, where do you start from. But when you have a new one, you have to plan, you have to build every stage, you build the model, the digital model, and finally you have a digital twin of the entire data center, what you are going to build. And that can remain for the life cycle of the data center. So you can change, and you can also ensure that how different scenarios of hyperscaling, scaling of the data center horizontally, vertically, they can be also addressed, this data center. Even before physically it is extended, you can have the virtually, extending it and then achieving it. So this is where the digital twin can help in redesigning, optimizing, training your people. And then the question is, when you have existing data center, so what do you do? So you need to define the KPIs in terms of the productivity, the energy efficiency, environment, security, safety. So these are the KPIs you can define, and then you can monitor, you can make an assessment of the existing data center, all the blocks, power, cooling, and the IT. And you can come up with a spider diagram, for example, with respect to this, where are you today? And then you can set the target that, okay, my thermal cooling block is very vulnerable, or the power is very vulnerable because we don't have any policy for addressing the cybersecurity there. So then you try to address them in terms of having a sensor, having the firewall, having the the defense in depth kind of approach, threat modeling, and then you install the system, the monitoring system, intrusion detection system, isolation system, and then you can again go back and do the assessment. So this can be done continuously, not that you can achieve this asset management and digitalization in one go. It can start from 3 months, 6 months, 1 year, you can do step by step. And this is a continuous exercise, and then the technology will also be sort of coming, new technology, and also new threats will be coming. So this is a continuous exercise, what is required for the asset management and the digitalization. So with that, I stop here. If there